the unit circle. So whenever you were in geometry, you were probably introduced at first with the trig portion where you had like sine, cosine, and tangent. Okay, where if depending on who you had, you may have learned about like opposite. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. So where all this fits in, okay, what happens is we try to find the set, or the domain is a set of real numbers. So then whenever we have a unit circle where the radius is 1, the center is at 0, where we can find all of the various points and what the angle measurement is and what the radian measurement is, depending on where it's at on the unit circle. Okay? Given that it's at kind of a special place and where, like what the length of the intercepted arc is. Okay? So we talked about whenever we had theta, depending on what it was, where your theta was in radian measure or in arc length, where you took the arc length and you divided it by your radius, okay, whenever we were in 4.1. So the big part, whenever we deal with radian measure, okay, is when the central angle is equal to the length of the the intercepted arc. So you have 6 different trig functions. The 3 that you're accustomed to, okay, sine, cosine, and tangent. It is not sin, it is not cos, and it is not tan. It is sine, it is cosine, and it is tangent. Okay, so please, if you say, what's sin? I don't know. Something people do on a daily basis, probably. Okay. CSC stands for cosecant. Then you have secant and cotangent. Okay. If you notice with the table, you have sine. The reciprocal of sine is cosecant. With cosine, the reciprocal of cosine is then secant. The only one that truly makes sense as far as its name is tangent and cotangent, as far as being reciprocals of one another. Okay, so whenever we talk about the reciprocal, obviously if we have sine of t, where t is any number, okay, and our point on the circle is just x and y. Okay, as far as the way we look at everything in terms of a trig function. Okay, the easiest way that I can tell you to remember that what is the reciprocal of the other one is if you notice you have sine, cosine, and tangent. Tangent and cotangent obviously should be the easiest one because one is tangent and one is cotangent. The easiest way that I can tell you to remember, because this is one thing that students, it's more with cosecant and secant, obviously, is that sine starts with an S, the reciprocal is going to start with a C, right? Whereas cosine starts with a C, its reciprocal is going to start with a S. Okay? That's the easiest way that I can tell you to try to remember. Okay? Because it is, I mean, if there is going to be any sort of mistake whenever you write these out as far as how it corresponds, it's going to be not usually with sine, not with cosine, not with tangent, not with cotangent. It's with what do I do? Which one is it? Is it sine? Does sine go with cosecant or does it go with secant? Okay? Sine and secant don't go together. Okay? Sine and cosecant do. Okay, so that's the easiest way that I can get you to remember is that sine starts with an S, so the reciprocal is going to start with the C. Whereas cosine, the opposite, it starts with a C its reciprocal is going to start with the s, okay, which is in terms is secant. So then down here where we have our points, it's in the yellow box. Okay, whenever we talk about the points on our circle, so whatever sine of whatever our value is, okay, that's a point on the circle, it's just going to be whatever my y value is. Okay, I don't care really so much about my x value as I only care about my y. The cosine value is just the opposite of that. In terms of, I'm not really worried about my y value because it's going to be whatever is equal to x. Tangent is the only one that I will use both terms. Okay, tangent and cotangent are the only two that I'm going to use both terms. Easy way that you can also write this is that tangent is just sine over cosine. All we're doing with any of these is trying to find like a triangle. Okay, is all we're doing. So if we're trying to figure out what is this angle, and I have to go to this point up here, and if this is my center, realistically this is all we're doing. We're just creating right triangles. Okay? The unit circle is just made up of millions of right triangles. It is all it is. So don't overcomplicate any of this. If I need to find whatever this angle is down here, depending on what information I have, is how I'm going to use it. Okay? Because if there's my angle, this is opposite, that's adjacent, and then this is my hypotenuse, right? Makes sense? Okay. What does my y value do? Does it go up and down, or does it go left and right? Whenever I find any sort of y value as far as a coordinate, what do I do? It goes up and down, right? So does it make sense that it's going to be the opposite side? Because what do I have to do? Don't I have to go up to figure out how tall that is? All right. If my hypotenuse is always 1 every single time, okay, because all this does is really just takes my circle. I did not do a very good job there. All it's doing is just running some sort of circle around those points. Again, didn't do a very good job drawing it. Where this is my center, okay, and that point that the red arrow is going to is just a point on that circle. Okay, so all it's doing, I can always create a right triangle somehow, some way. Okay, no matter what, because I can always draw a vertical line, and I'm always going to have a horizontal line that I can draw on my x-axis somewhere. I can always draw a vertical line that may be on the y-axis, but that will be parallel to the y-axis. Okay, it's just all the unit circle is just a compilation of right triangles. Okay, with each very individual part. So then, if I have a point, okay, it's at 1/2. Let's see if I can zoom in a little bit. So it says, use the figure to the right to find the values of the trig functions at t. You're just going to write these as fractions. Don't worry about writing them as decimals. Just write them as a fraction. So all I want to do, I have my x value and I have my y value. So I have 6 things that I have to find. Sine of, in this case, t is equal to, what is it always equal to? Sine is always equal to my, what did we write down from the previous page in the yellow box? What is sine always equal to? Y. Okay. So what is my y value? Square root of 3 over 2. Okay. I'm only going to use those values. So sine is just going to be the square root of 3 over 2. What is cosine of t? What does cosine always use? My x value. So what is my x value? Negative 1/2. Now, here's where it gets a little bit tricky. And it's not that it gets tricky, it's just you're going to have to do a little bit more work with it. So tangent of t, well, remember, what is tangent? What is it? Sine over cosine. So what's sine? Square root of 3 over 2. So basically I'm going to have a compound fraction. I'm going to have the square root of 3 over 2 divided by, I'm going to call it negative 1 over 2. So I've got to simplify it. I can't leave it like this. So all I'm going to do, if depending on how you want to leave it, if you want to leave it stacked, and I'm going to go outside and inside. So that's just 2 times the square root of 3 over negative 2. Well, what's going to happen to the 2 and the negative 2? They're going to cancel. So I'm just going to be left with negative square root of 3. To be perfectly honest with you, the ones that are going to be the most work are going to be the tangent and the cotangent. Okay? Most likely. So then, we still have to find, excuse me, the other 3. So, which one's going to go? So I have sine of t. So which one's the reciprocal of sine? Huh? No. Cosine, sine, cosine, and tangent all go together. They're the originals. So what's the opposite, or what's the reciprocal of?
1 over sine.
Right. What do we call it? What trig function do we call it, though? Cosecant. Okay. So cosecant of t. So what do I need to do with the square root of 3 and 2? I need to flip it, right? Now, can I leave a radical in the bottom? No, so how do I get rid of that radical? Square root of 3. Square root of 3. So what's the top going to be? 2 square root of 3 over?
So, how did you get
The opposite, okay, or the reciprocal of cosine, then is going to be, is it going to be secant or cotangent? Secant, right? Cotangent's going to go with tangent. Now, just like we did here, we flipped on sine, we flipped the square root of 3 and the 2. We flipped them over here with the cosecant, we made it 2 over the square root of 3. What am I going to do with the negative 1/2? What is it going to become over with the secant? It's still negative. The sign's not going to change. Just negative 2. Okay, because what is that? It's really negative, and I'm going to write it as negative 2 over 1, right? Because what did I do? All I did was just take I made the 1, sent it there, I took the 2, sent it here. We just flipped the order, okay? Flip the spot is all we did. Now, I'm realistically going to just write it, like you said, as -2. I have no issue. If you want to leave it as -2 over 1, okay, especially right now when it's early, I have no issue in that. Okay, as we go, obviously you'll start to simplify it. Now, tangent's the same way. So if tangent is -√3, what is cotangent? What do I need to do? Does the negative change? Nope, still going to be negative. Okay, so it's still negative. Now it's going to be a fraction. So here it's the √3 over 1. So now what is cotangent going to be? 1 over the √3, right? So if I have 1 and then I have the √3, I can't leave a radical in the bottom. Right? So I have to multiply the top and the bottom both by √3. So it's just going to be negative √3 over 3. The nice thing about any time that you have to rationalize your denominator, it's going to be a nice, neat, easy number. Okay? It's going to be something, and if you notice, it's going to be like a √3, a √2. It's not going to be anything that's just going to be so totally out in left field. It's going to be a pretty easy number to deal with. Okay. Here it says find the trig values of the function when t is at pi over 2. So it's on the y-axis. Okay? So since it's if you think about it, what kind of, okay, and this is what we're talking about, or this is what I'm talking about, all we've done is just made a right triangle. Right? All we did was make a right triangle. What kind of triangle is this? If my 90-degree angle is down here, what kind of triangle is it? It's a special right triangle. What are these two angles here and there? How much? Right? So it's just a 45, 45, 90 triangle, right? Okay? Okay? All we're doing is just making triangles. Okay? So don't get so caught up in what does everything have to do. Take your time and go from there. Your 0 is still your x value. Your y is still your 1, or 1 is still your y. I still need to find what sine of t is. So what's sine always equal to? Sine's always equal to my y value. Well, what's my y value? 1. My cosine of t is always equal to my x value, which is 0. And then my tangent tangent's equal to is it sine over cosine or is it cosine over sine? Sine over cosine. So if it is sine over cosine, what is sine? 1. So it's 1 over 0. Can you ever divide by 0? So So it's undefined. Okay? Or I would usually say, yeah, I would just call it undefined. If you want to put the circle with the slash through it, that's fine too. Then, same thing. Now, instead of sine, excuse me, we're going to have cosecant of t. So what do I need to do with the 1? Take it, flip it. So what's the reciprocal of 1? 1. What about secant? Why? I agree.
Yeah.
But why?
0 is technically 0.
Right. 0 over here is 0 over 1. So whenever we flip everything, we really make it 1 over 0, which is undefined. Good work. And then the last one. What about cotangent? Is it going to be undefined just like tangent? Or if it's 1 over 0, if tangent is 1 over 0, what's the reciprocal of 1 over 0? 0 over 1. So it's just 0. Now, the easy part here, I believe, would be the easy part as far as my domain and my range of sine and cosine functions. Okay? So whenever we talk about if sine is equal to your y value, we're always going to be working with negative infinity. So the domain of any sine function and cosine function is always going to be negative infinity to positive infinity. Okay? Where the range of these functions, okay, is from -1 to +1. Okay? And the set of all real numbers from -1 to +1 are inclusive. So basically, because it's a unit circle, it's going to be anything from anything from -1 to +1, because no matter what, your center is at 0. It's only going to go as far as your circle can go. Does that make sense? Like, you can't go past if your radius is only 1, like if the string or the chain that the dog's on, okay, is only so long, it can't go past it, right? If it's still going to stay on that, okay, unless it breaks the chain, but you get the idea. So you can only go as far as the length of your radius. If the unit circle is always a radius of 1, it's like if you think about, and I didn't do this in your class, but like the wind question, okay? I can only touch as far as my fingertips, right? Makes sense? Okay? Even if I spin around in a circle, and I go, whee! All right? I'm only going to be able to touch as far out. I'm never going to, if I stand here at this point, I'm not going to be able to touch any wall or anything around me. Make sense? I'm only going to be able to go as far as the radius allows me, or basically from the center of my body to the tip of my fingertip. Does that make sense? So if the radius is always going to be 1 of a unit circle, the furthest part as far as the range that it's going to go is going to be from -1 to +1 because it's got to go in both directions. Right?